Hi, this is Mr. Mazan. I'm making these videos for my students who get stuck at home, or if you're absent and you want to catch up on a lesson. These first couple of videos are probably review for 3rd grade. Right now it is June 1st of 2017, so you may be watching this in 2018, 2019, just depends on when you're taking 4th grade math. So welcome. The first thing we're going to talk about in today's lesson is commutative property of addition. Let me grab a marker. Commutative property of addition just means that you can take the two add-ins of a math problem and switch them and get the same answer. So 3 plus 7 equals 7 plus 3 because they both equal 10. Alright, the next thing I want to talk about is place value and neatness. You have numbers 1 through 9, and those numbers can go in different places. The place value is determined by where that number is in relation to the decimal. So if the decimal's here and you have 27.48, the 7 right here is in the ones spot because it's right next to the decimal point. And this 2 is kind of hard to see, so let me make it a little bit bigger. Okay? What place value would the 8 have? Well, since it's 2 to the right of the decimal point, what's 2 to the right? The 8 would be in the hundredths spot. The next thing I want to talk about is neatness. Whoosh. Neatness is very important in math. A lot of times kids know how to do math, and they miss problems because numbers aren't lined up. Whenever you add a number, so if you're going to add 34.28 plus 17.95, notice the decimal points are lined up perfectly. I wouldn't want to accidentally put the decimal point over here or anywhere else. A lot of kids do this, and then they add the wrong numbers and things just get mixed up. Not because they don't know how to do the math, but it's because they weren't very neat. Another thing kids do that that gets them confused is if they start their problem like way over here, 34.28. You're running out of room. You got to use your space. Or if you write 34.28 plus 17.95. And then in this little tiny space over here, you try to write your answer, and then you write so small that you can't see what the numbers are, and you mistake a 7 for a 1 or vice versa, and then you miss a number that way. So make sure you line things up perfectly. The numbers in the hundredth spot should line up. That's Israel, my son. And the numbers in the 10th spot should line up. Same with the ones and the hundreds, or the ones and the tens. Everything should line up. Hi, alright, our first example of today is 345 plus 67. Notice the 5 is in the ones spot because it's right next to the decimal. A lot of times you won't have the decimal there when you don't have fractions or decimals to the right of it. So it's just, this is 345 plus 67. But you can, if you want, put a decimal there. 5s and the 7s, like I said earlier, are both in the 1 spot, so we're going to add in columns. 5 plus 7 is 12. The 2 is going to go directly below the 7. Carry the 1. 4 plus 6 is 10. 10 plus 1 is 11. So I'm going to put a 1 right there and carry the next one. And 3 plus 1 is 4. Alright, so the commutative property of addition says that if 345 plus 67 is 412. Then you can switch the two add-ins. 67 is an add-in, 345 is an add-in. You can switch those, and you'll get the same answer over here. I made a mistake here. I did this on purpose because I want you to realize that things aren't lined up correctly. The 7 is in the 1 spot because the decimal would be right there. And the 5 is in the ones spot. They are not lined up directly. The decimals aren't lined up directly. So let me find my eraser really quick. In order to fix this, you're going to take the 67, erase it, move it so that the 7, which is in the 1 spot, is directly above the 5, which is also in the 1 spot. And then the decimals will line up. Then you just add it. 7 plus 5 is 12. There's a 2. Carry your 1. 6 plus 4 is 10 plus 1. 10 plus 1 is 11. Carry your 1. 3 plus 1 is 4. Does 412 equal 412? The answer is yes. And so the commutative property of addition works. You can switch add-ins and get the same answer. Alright, here is example number 2. So we have 3 values. They're money values. Notice the money sign there. And we're going to add them up. It's like you're at a store and you wanted to buy 3 items and add them up to see how much your total would be. Okay, so the first thing I'm going to do is I'm going to look at this $5 bill here. Notice we have a number in the tenths spot and the hundredths spot for each of these. For $5 over here, you just have a straight up 5. So what you want to do is you want to add a decimal and add 2 zeros because there's nothing in the tenths spot or the hundredths spot. Then you're going to rewrite your problem vertically. Make sure you have enough room on your piece of paper so that you're not at the bottom of your sheet of paper running out of room trying to write this stuff. Okay, first one is $1.25. So just write it. If you write $1.25 there, on the next line in your on your homework page, write a decimal, and then on the next line, write another decimal, because that's where the next 2 quantities are going to go. So you're going to take 12.50. Notice I'm taking care that if the 2 is in the tenths spot, the 5 is in the tenths spot, and the 0 is in the tenths spot, that those numbers will line up in a straight column. Okay? So then I'm going to take the 5, put it there, and then 2 zeros. Now I'm going to add these. Okay? So 5 plus 0 is 5. 2 plus 5 is 7, plus 0 is 7. Bring your decimal point straight down. 1 plus 2 is 3. 3 plus 5 is 8. Don't have to carry anything. And then there's nothing to add to this 1 that's in the tens spot. So you're going to bring that 1 straight down. So your final answer is $18.75. Make sure your mom's okay with you spending that much money. Okay, we're going to talk about another property. It's called identity property of addition. You might want to write that down. Identity property of addition means that if you take a number, 5 for example, and add 0 to it, you're going to get the same number you started with, 5. You actually use this a lot in algebra, so it's important. When you add 2 numbers, the 2 numbers are called add-ins. When you subtract, the 2 numbers are called minuend and subtrahend. Whenever you see the word difference, we're talking about subtraction, right? Subtraction. Okay, minuend, that's the first number. So if you're going to take 7 and you're going to find the difference between 7 and 2, the difference would be subtraction. That's how you would write it. 7 minus 2. The minuend is the first number, and the subtrahend is what you're subtracting from the first number. And clearly the answer would be 5. That would be your difference. 5 is the difference between 7 and 2. That's how different they are. So we're going to do example number 3, which is 345, which would be the minuend, and we're going to subtract 67, which would be the subtrahend. We're going to find the difference between those 2 numbers. First thing you're going to do is you're going to add or subtract them by lining them up vertically. 345, the decimal's there, and then we're going to put 67. I made that same mistake again. I need to take this 67, and since 7 is in the 1's spot, it needs to be directly below the 5. So let's erase that. Put the 67 there, because that's where the decimal is, and we want to line decimals up when we're adding and subtracting. So we're going to find the difference between those 2 numbers. 5 minus 7. You can't take 7 away from 5, so we're going to borrow. You can't take 6 away from 4, so we're going to borrow again. So there's 2 left in the hundreds spot. Then this is going to be 14, but the 5 still needs to borrow from the 14. So this is actually going to be 13, and this is going to be 15. Okay? 15 minus 7 is 8. 13 minus 6 is going to be 7. And 2 minus nothing is 2. So your answer is 278. That's the difference between those. Alright, example number 4. Joe spent $1.25 on a hamburger. He paid for it with $5. How much change should he get back? This is definitely a subtraction problem. You start with $5, and you're going to pay for a hamburger that costs $1.25. Order matters. We are going to take $5. That's the menu end. That's what's going to be diminished. And we're going to pay for it with $1.25, which is the subtrahend. We're subtracting $1.25 from $5. Make sure you don't mix these two numbers up. You're not taking $5 away from $1.25. You're taking $1.25 away from $5. Okay, so you can't take away 5 from 0, so we're going to borrow from there. There's nothing there to borrow, so we come over here and we borrow 1 from them. Then this is a 10, but we still need to borrow for the guy in the 10th spot, so you're going to cross him out. He's now a 9. Now we have 10 in the 10ths in this spot right here. So 10 minus 5 is going to be 5. 9 minus 2, 7. Bring your decimal straight down. 4 minus 1 is 3. So you have $3.75 left. If you want to check this problem, clearly we're subtracting down, but if we want to check to see if this is correct, we're going to add up. We're going to take our difference, which is $3.75, add that to our subtrahend, and we should get $5. So let's take $3.75. I like to do it right below. Add $1.25 to that. $3.75 plus $1.25, 5 plus 5 is 0, or 10. Carry your 1. 7 plus 2 is 9, plus 1 is 10. Carry your 1. 1 plus 3 plus 1 is 5. Those two numbers are equal, so you are correct. So we're going to rearrange this number right here to create a fact family. We're going to write another addition fact and 2 subtraction facts from this one. So if you take 14 plus 11, that's also going to equal 25. Now we're going to do 2 subtraction problems. So if you take 25 minus, pick one of these add-ins up here, let's say 11 since it's first, your answer is going to equal 14. What do you think the answer will equal if we pick 14 as our subtrahend? The answer will be 11. That's a... Alright, commutative property of addition means you can switch these two numbers. 11 plus 14, 14 plus 11, doesn't matter, you still get 25. But if you are doing a fact family and you take 25 minus 14 and you get 11, you cannot switch these two numbers when you're doing subtraction. So, if I were to take 14 minus 25, it does not equal 11. So you cannot switch these numbers when you're doing subtraction. That only applies when you're doing addition.